Good evening, everyone. So welcome to my YouTube channel, Math Doctor. So today we are going to see the first lecture on commutator circuit. This is a new topic. Okay. So what is the commutator? First, we will have to understand what is the commutator. Commutator. Let G be a group and A, B belongs to G. Then element A inverse, B inverse is called commutator of the ordered pair AB. Okay, A comma B. Okay. Now we write U is equal to A inverse B inverse such that AB belongs to G. Where G is a group. Okay. So G is a group. Very frequently we will use U. Okay. During the lectures on commutative subgroup, we will use U very often. Okay. So remark U is equal to U inverse. Sorry. U is equal to actually A inverse B inverse AB. We can also write it. AB belongs to G. So how it will be proved? Since J is a group, we have G is equal to G inverse. Okay. G is equal to G inverse. Therefore, U is equal to A inverse B inverse such that AB belongs to G. Okay. So because G is equal to G inverse, so we can replace A by A inverse, B by B inverse, and A inverse by inverse, B inverse by inverse. Okay. We have such that AB belongs to G. So what is this? This is nothing but A inverse D inverse. The inverse of, you take inverse of A inverse, that is A. You take inverse of B inverse, that is B. A B belongs to B. So this implies U is equal to A inverse B inverse A B, such that A B belongs to B. So it is proved now. Okay. So you can write U in two ways. Okay. Next, what is the definition of commutator subgroup? Commutator subgroup. Let G be a group. Okay. The subgroup, G dash of G generated by U is called the commutator, is called commutator subgroup of G. Okay. So note that since G dash is generated by U, therefore G dash is the smallest subgroup of G containing U. If you take a subgroup generated by some set, then the subgroup obtained is the smallest subgroup containing that set. Okay, it always happens. Okay? So it means what does it mean? Mathematically, what is the meaning of this? It means Q containing G dash. Okay. So what does it mean? This implies because U contain A, B, A inverse, so it means A inverse, B inverse belongs to G dash for all A, B belongs to G. Okay. Because U is nothing but the collection of all the elements of the form A, B, A inverse, B inverse, where A, B belongs to G. Okay. So now we will prove a result. The theorem. Let G dash be the commutator subgroup of G, then G is abelian if and only if the commutator subgroup is nothing but identity. It means commutator subgroup contains only identity element. So let's see its proof. assume that G is abelian, then since G is abelian, then then AB will be equal to BA for all AB belongs to G. So this implies A inverse B inverse is identity for all AB belongs to G. Okay. Okay. AB belongs to G. So this implies U is equal to AB A inverse B inverse AB belongs to G is nothing but contains only one element, that is U. Okay. Okay. So we have to find now G dash is equal to the subgroup generated by U. It is equal to E. It means smallest subgroup of G containing U is equal to E. And we know that E is itself the E, if we take E only identity element, that is also a subgroup, and it contains this set U. So what is the subgroup, smallest subgroup containing only identity element? Because U is here contain only identity element. So E is itself, because smallest subgroup containing a set, that is U, that is contains only E element, that is E itself identity element. So it means, so what does it mean? It means G dash is equal to E. So it is proved now. One side is proved. One side is proved. Okay. Now conversely, assume that G dash is equal to E. Okay. Since G dash is the commutator subgroup of G. Okay. And what is the, it means G dash is generated by U is equal to A inverse B inverse such that AB belongs to C. So because G dash is generated by U, it means G dash is smallest subgroup of G containing U is equal to A inverse B inverse such that AB belongs to G. Okay. Now G dash contains U. Okay. So G dash contains U. So this implies G dash contains U. It means U is contained in G dash. But G dash is, what is the G dash? G dash is nothing but E. And what is U? U is nothing but A inverse B inverse. AB belongs to G. Okay. Okay. So what is this? So what is U? U is nothing but, so this implies U is nothing but A inverse B inverse, such that AB belongs to G, but that containing G dash, but G dash is identity element. So this implies A inverse B inverse is identity element, because each element will be this, because this have only one element. Overall AB belongs to G. Okay. Because this set is containing G dash. G dash contains only one element. So AB A inverse will be equal to identity. Each element will be equal to identity. Ultimately, this is subset of this. So this implies AB is equal to BA for all AB belongs to G. So what is the meaning of this property? This means G is commutative group, and commutative group is called abelian group. So this implies G is abelian. Okay, so it is proved now. So reverse direction is also proved. So today's lecture up to this. If you have any program related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for following lecture. Thank you.